Good morning, everybody. My name is Kevin Renaud with Peerless. We're pleased to be back with you for another Wednesday e-learning session. This week we have Brian Isom with J-Flow Controls. J-Flow Controls is a manufacturer of ball valves, control valves, and actuation. We had originally approached them to do actuation, but Brian and Ken there thought it would be a great idea to start with a basic overview of ball valves first. So with that, once again, we have a very packed room. This was really well received, this topic, so we're anxious to get going. Many countries, many states involved, and certainly many industries. So again, Peerless, we've been around for a long time. We have become a trusted source for process components that keeps plants operating efficiently and projects running smoothly. And again, we are proud of the role we've played with many of our customers, navigating some tough challenges. And I'll end the presentation with some projects that we have been involved in. So we operate under three main segments: the ProCore division, where we work with OEM customers and skid builders, and the process side of things, where we deal with our MRO type supply, and finally our high temp fabrication division, where we work with high temp insulation, pipe valve insulation, refractory, and laboratory surfaces. So again, Brian Isom is the National Sales Manager with J-Flow. They're out of Cincinnati, Ohio. From the Peerless side, you have Dan Morgan with us, Greg Barrell that works our process group, and me, Kevin Renaud. So I asked Brian a little bit about himself, and he did say he's a valve enthusiast. In fact, he's always considered J-Flow to be the Cadillac of the industry, but he's also a classic car enthusiast, having owned a couple of 1965 Lincoln Continentals, both hardtop and a soft top, and there he is. Looking good, Brian. Looking good. So speaking of looking good, I am going to turn it over to Dan Morgan, who will talk to you just briefly about the platform that we're working this meeting in and how you can play an interactive role in it. Dan, take it away.
Thank you, Kevin. I think I looked similarly as good as Brian in my my Ford Taurus. It was also white, not quite a drop top like that, but either way, just to explain a few things here, in a couple minutes, couple seconds really, I'll turn this presentation back over to Brian, and he'll get us underway in his presentation. But as he's going through here, through his presentation, we do, want to encourage you all to ask any questions that you might have, because it obviously makes most sense to talk about things and answer questions that are going to help you the most and make most sense to you. So in your control panel, you'll see a pane labeled questions. So at any point throughout Brian's presentation, if you have anything that you want some clarity on, or an application specific question that you feel is applicable, please feel free to submit your questions through that panel, and I will be keeping an eye on those, and then finding some moments during the presentation to interject and ask those of Brian. It's also possible we'll save them up for a question and answer portion at the end of the presentation, or we might need to follow up with you after the presentation entirely. So please do submit anything you feel like asking, and we'll make sure to get you an answer. And then another quick thing to just mention, and also in the control panel, you'll see a pane for handouts. And there's a couple of good pieces of literature in there from J-Flow. One is their condensed brochure of their entire line of products, and then the other one is specific to ball valves. So good reference points there. So you should just be able to click on the link and it'll take you to the PDF download. So with that, I will turn this over to Brian.
Can you hear me okay?
We can hear you, yes.
Okay, let's see if we can share my screen here with you.
Looks good.
Okay, good morning. And again, I wanted to thank you guys for having J-Flow be a part of this overview on ball valves. We want to thank you for the opportunity today. And a few basics to get started in this. Some may or may not know. We hope that this is informative and educational to you in your decisions on ball valves and their applications, their respective applications. So we'll dive in real quick. Here's a brief overview of our company. We have been in the valve business for over 20 years in manufacturing. The amount of experience that is in this building There's over 50 years, probably plus, of combined, excuse me, experience. We are located here in Cincinnati, Ohio. We have offices throughout the world. We have a big presence over in the Middle East. We have a big presence in Kazakhstan. There are several places that that we are in and are starting to make inroads with throughout the world. So we do comply a lot of times to manufacturers' standards, international standards as well. And we offer a lot of unique products. At the very bottom here, we will show you our, we not only manufacture ball valves, but we manufacture slap gates, actuation, automation, our globe valves, expanding gates, pneumatic and linear, pneumatic, linear, and rotary globe control valves, electric, hydraulic, electro-hydraulic, pneumatic actuators, and including the floating ball valves, butterfly valves, high performance, trunnion, and severe service valves. So. Got a brief history of the ball valve. We're not going to spend a lot of time on this. We're just going to go through this. The ball valve was actually invented in 1949, but they could not find or think of a commercial use for the ball valve, so they just kind of let it go. And then it was actually branded or brought up from resurrection and invented in 1957, and they commercially put it out in 1967. So you would think that the ball valves have been around a lot longer than they have, when actuality is they were commercially available since 1967. The ball valve revolutionized the valving world, because before this, the plug valve was king, and plug valves were everything to everyone. And the ball valve itself had found many, many applications, as you all probably aware, and the advancements that were made into the ball valves and the seating and body materials, able to withstand greater temperatures and pressure, and overall performance, have made it a stable item and a standard in most industries where they allow, the ball valve and the selected materials, as long as it is met. So the industry served usually for ball valves is the petroleum, water, electric power, paper, chemical, pharmaceutical, food, and many, many others. As we get into the floating types valves, you will see a lot of times you will see one piece, which is a unibody, and that could be also flanged. We put on here threaded, but the one piece unibody threaded is typically what you will see for a one piece valve. And we'll get into these applications, kind of where they belong and how we use those. Two piece are generally threaded, flange grooved, tri-clamp-ins, seal welded. The three piece are threaded and can be flanged or grooved or tri-clamp or even top entry. We have a double blocked bleed valve. We have to meet fire safe designs a lot of times. And the nice thing about most valves today is they direct mount. So they eliminate the requirement, if it's a standard temperature type application, to eliminate bracketing. And as you know, that always adds expense. So if you see the pictures to the right on the actuated, electric actuator, the red actuator, you will see that it's directly mounted to the valve, and we do not require a bracket or a coupler. The typical sizes that you will see for us, or for most valve manufacturers, is 1/8 inch through 10 inch on floating ball valve designs. Any questions?
Nothing yet, Brian.
Okay. So real quickly, the principle of operation, the picture to the left, you will see the valve in the open position. We kind of did a quick sketch here, as the blue lines will indicate the seats and the flow going through the valve. in the open position. As we close the valve, you will see that the ball is now closed, and we're pressing that seat to the downstream. So the actual pressure for ball valves, the upstream pressure is pressing that ball because it floats into the downstream seat, and that is where our seal takes place. Now, some people have seen the ball and stem together, and this is kind of how they work together, is the stem has a groove and it fits the top of the ball. Our balls are all vented. If you'll see that middle picture, top row, and for chlorine and other applications, you'll see that we'll drill the ball and we vent the ball for downstream and upstream control. So the picture to the right, the far right, you kind of see how the ball slots in there, fits in there. There's a seat, and that was taken with a white background, so it's kind of sometimes hard to see. And the lower left picture, you will see that it is anti-static. So a lot of valves are required now with an anti-static device, and that is how it is addressed. So looking again at the picture, what we're doing is we're actually closing the valve, and the upstream pressure is forcing that ball into the downstream seat to provide a tight, bubble-tight shutoff.
Hey, Brian.
Yeah, go ahead.
Sorry, before you dive into this one, we did just have a quick question come in. You talked about actuation and direct mount a couple of slides ago. Question just came in. Does the valve sizes 1 inch and below allow for actuation?
Yes. If the way that most valve manufacturers nowadays, the cost of bracketing and coupling increases the cost, especially smaller valves. Ours all direct mount. If it is a 1 inch, we direct mount all the way down to, I believe, 3/8. If it's 1/4 inch, then I believe it is a double D stem, and that would require a bracket coupler. But yes, we do, because it is so much easier to put the actuator directly onto it, and it saves a tremendous amount of cost, especially in the lower and smaller sizes. So yes, we do. There are a lot of other valve manufacturers that have gone that way now too, just with the simple fact of automating these valves. So you'll see that the bulk of our valves, or any valve for that matter nowadays, all come with an ISO mount for automating. And ours are ISO direct mount. So we just put our actuator directly onto it, and it makes automating a very, very simple process. Even if you bought a valve manually, you decided later to automate it, it is very, very simple for us to either send it to the customer or give the instructions to the contractor to tell them, hey, this is how easy it is, and off they go.
Okay, perfect. I will let you know if there's any follow-up to that, but it sounds good for now. Thank you.
Great. Another type of valve floating is a 3-way or a multi-port, as we call them. We do 3 here. We do 3, 4, and 5-way. So you can clearly see the 3-ways that we have displayed. I didn't have an actual picture of a 5-way. So if you could picture that center valve up there with the red actuator on it with a flange coming down, what we do is we take an L ball in a vertical L, and we come in through the bottom, and we use it as a selector valve to go to 4 different ports. So we have 1 being the inlet and 4 outlet. That makes it our 5-way ball valve. So it's I wouldn't say we sell a lot of those, but it's a specialty application, and it's typically for selecting a certain line for a certain amount of flow to push one way or the other. And these valves, a lot of times we are seeing typically the applications that you see to the lower left. We get into a lot of oil and gas, where we see black unit, lease acquired custody transfer, reject valves on the LAC unit. We see them on the group headers. We see them in production and manufacturing for line diverting and switching flow, mixing, where we're combining flow, and even a double L or a four-way where we are splitting the flow. So, and of course, as we mentioned, the selector valve, the five-way. And we offer these in from ANSI 150 all the way up through ANSI 1500. So we're one of the very few that still do that. Any questions so far?
Not right now, but actually one thing to mention here as a follow-up to the first question about actuation is there is an intention to have a future webinar with Brian where we do talk specifically about actuation. So that's something to look out for in the next couple of weeks as that's on the table. So, but no more questions at this time, Brian.
Okay. Just want to make sure I'm not putting anybody to sleep yet. So three-way configurations, typically this is what we'll ask a customer, and these are the available porting for our standard 3 and 4-way. To convert the diagrams you'll see the starting position 1. I don't know if you can see that real well, but it's very small. Starting position 1, ending position 2. So we have L3 where we rotate counterclockwise to end at position 2, position 1, position 2. So when a customer calls and says, hey, I need a three-way valve, typically what we need to know is what's the inlet. Are we using left to right, right to left, inlet to right? So we typically talk in clock fashion. In other words, we're entering at 6 o'clock and we're exiting at 9 o'clock, let's say. So this is kind of how most manufacturers that I have seen, you know, friendly competitors. We have a lot of friendly competitors in this industry because not one valve company that I know of has everything and can do everything. And we strive hard to do that. But, you know, there are a lot of other manufacturers out there that use this exact same configuring port diagram. Any questions here? Okay. Valve selection considerations. Okay. Most of you will know to choose a valve depending on your application. Okay. So when we get applications come through, the first questions and things that we ask, is it manual or automated? The automated or actuated valves will ask pneumatic, electric, or hydraulic, which is it that we're going to be doing? And then we want to consider the process media or the fluid type or the gas, liquid, or vapor, and what it will do to the valve material that we're selecting for you. A lot of times, some customers will say, you know, it's a flow line out in oil and gas, or it may be, you know, a water line. So for us, typically, you know, Teflon is a good starting point because it is resistant to a lot of processes and corrosive chemicals. So we want to determine the temperature, pressure, and flow rate. So a lot of times you'll see on most valve manufacturers, including ours, we provide the CV or the flow coefficient in our brochures for each valve that we manufacture. So whether it's a 2-piece, 3-piece, flank valve, all of our CVs are put in there for engineering practices to be able to see. And typically it's the white spot in the line. You know, that's what we always say. So ANSI class is important to consider. What is our working pressure, the flow coefficient, and the maximum allowable working pressures and temperatures. Temperature plays, pardon me, a huge part in consideration. So if we know that you're going to have a much higher elevated temperatures through a process, then we'll make the recommendation to put you into a different type of seat that or body seals, depending on what it is, that will withstand that pressure and temperature that is required. For actuated valves, a lot of times, you know, a customer will say that they need a very quick closing or a very quick opening. So that is something to consider. And how long will it be energized? How long will it be open for? The duty cycle. This is come up many times for customers for duty cycle and the voltage for electric actuators. Duty cycle is typically the amount of time that it's on and the amount of time that it needs to rest and cool down before it does it again. So some actuators are rated for stops and starts per minute. Some are rated for duty cycle and how long percentage-wise that they need to be on and off. So you could have a 100% duty cycle, which means that it doesn't require any time for cooling off. 50% duty cycle, which requires it to be on for 50% of the time and off for 50% of the time. So it's some things to consider. Solenoid valves for on-off cycling. If we know that the valve is going to be cycled continuously on and off, sometimes Teflon may not be the best seat for that valve due to the amount of cycling that is going to be required. So there's another thing to consider. We're choosing, a lot of times it happens to us more than we like to talk about. We'll get an order in for a normally closed or failed closed actuator, and 9 times out of 10, it happens that someone needs it open, fail open. So it is something to consider, and I know it's elementary at times to think about these things, but it is something to consider. So, and then consider the maintenance requirements. Ball valves do resist a lot of plugging, and they are by far the easiest to service. And selecting a ball valve that has been around for a long time, the patterns don't change. As our valves, we've had the same patterns for the last 20 years. So the same repair kit for our valve fits the valve that was manufactured 20 years ago. So there's no guessing. So your return on investment is low. You can reuse that body over and over, and the ball, provided it's good, over and over and over again. So there are some maintenance considerations to think about, and we'll show you some of that here in just a minute. Any other questions?
Yeah, there is actually a question. It's application specific, so there's a chance we'll need to dive in and maybe get some more information to give a complete answer. But essentially, this attendee is saying that well, this question was submitted that they use a lot of adhesive products, and they experience issues where the valves get stuck in place. So is there anything you maybe comment on like some types of options or maybe valve type specifically that could help with that situation?
There are, well, one of the things that we offer is, depending on the application, of course, we know that we probably need some details about the process or the media that's going through there. But we can offer a Teflon coated ball and a Teflon coated ball valve body. So if the adhesive is sticking to the body or sticking to the ball or just sticking into the valve ball itself opening, there's a lot of things to consider, to look at where it would not possibly stick to some of those things. The other thing that we might recommend is even a segmented, which we make a segmented valve where it has a half a ball in it that may prevent the clogging. So there's a couple of things to look at, and I'd really like to get more information on that. That's great.
Okay, perfect. Yeah, we'll follow up and maybe get some more details on that and have a separate conversation after the webinar.
Sure, love to do it.
All right.
So valve selection considerations continued here. Body materials, typically in the general applications, we'll see carbon steel, WCB, 316, stainless steel, 304. We can do alloy, Hastelloy C, super duplex, bronze. There's PVC. We do not manufacture or offer PVC, but there are ball valve manufacturers out there for those acids and slow and low type applications for PVC. But there's a ton of other materials that are selected and used for certain processes that may not be listed here. Cast valves versus forged valves. Cast valves are an investment casting. We can pour valves and over again, and these are typically low cost. It's repeatable, and we have a good success on our cast valves. Now the forged valves, a lot of times they're preferred because they can provide little or no porosity in the castings themselves. So all of our valves are checked for porosity, but the forged valve is a much higher quality. There's no porosity. They're generally used for extremely high temperature. The low temperatures, we can do the low temperatures in the LCCs and stainless, depending on which temperature we're going down to in these low temperature ranges. So forged valves versus cast valves. So any questions about that?
Not at the moment.
Okay, just want to make sure I wasn't going too fast or too slow. I didn't want anybody falling asleep here. One of the things that are nice, if you know that you're needing a one-piece valve, you know that it's going to be typically economical, a two-piece or even a three-piece valve, flanged even for that matter. Most of the time, you'll see these one-piece valves. They're non-repairable, most of them. The seat options are limited, and their working pressure is typically limited. Two-piece, they will either have a threaded breech or the body will split in half, where we can unthread it, take the seat out, take the ball out, and take the stem out, and we can repair them up to a certain point. Most of them are seal welded, to where if a guy puts the valve in line and they decide to change that particular piece of piping, when they unthread that pipe, you know, the end cap is not coming with it, so we provide a seal weld to keep the valve body from splitting in half, and those are actually non-repairable, but it is a nice feature to have. So on the one-piece valve, you'll see there is not a mounting pad for those, and again, typically those are not automated. Usually they are just a low-cost option for something that you need in the line to get the job done and move on, and it's typically not a huge investment involved there. So your seat options are limited in the one piece. The two piece, you have more seat options, but not as many as you would with a three piece or a flanged design valve. The nice thing about the three piece valves is, as you see the end cap bolts at the very bottom picture of that valve, we remove those end cap bolts, and we can rotate that center section out, and you can repair the valve, put new seats in it, put new ball in it, new packing, whatever it is that you need, without having a crew or maintenance take the valve completely out of line. So the advantages for the three-piece valve is not only working pressure and temperatures and seat options, but the maintenance side of it as well. So there are a lot of considerations for how you want to maintain or keep these valves in your process and what you're wanting to do as far as the maintenance side. Any questions so far on this?
No questions, but I actually do have one request of you, Brian.
Sure.
If it's possible, could you try using your mouse on the screen here to possibly like point out and highlight some of these features?
There you go.
Yes,
all
absolutely.
Right.
That's great.
So yeah, you'll see, well, see, I'm using my mouse. You take a look at this, you'll see there's no mounting pad. Here we provide an ISO direct mount for this valve, and the same thing here. We simply remove the handle, the locking nut, and all of our valves that you see that have the DM are a live loaded packing, and we'll get into that to where we have a quality seal where we don't have leaks. Same thing for the body seals. When you remove these bolts on this three-piece valve, this center section rotates out. You can leave these two bottom loose, and you can rotate this valve out and easily get to the body seals, the seats, and stem and ball, whatever it is that you need to do, or completely remove it from the line where this stays in line.
Perfect.
Okay. Packing. The one thing that I wanted to tell you, I don't know if you can see this real clearly, but most of the valve manufacturers today, we've done it since the beginning. There is a line that we have. Now our stems are not a square. They are square, let's put it that way, but they're on a 45. So when you look at the top of this valve, because a lot of times, even on the three-way valves, they are stamped. because if a maintenance worker comes across and says, hey, this actuator needs to have some maintenance done to it, and they take it off, how would you know where that valve is in the process? So the valves on our valves are stamped at the very top of the stem with an E, with a line. That means that across the valve it will be closed, or inline, meaning open, a T, an L, an X, or double L in this case, and it would show you that which ports are connected, how the ball is in the process, so that when you put the actuator back on, you put it back in the right position. Does that make sense?
Does to me.
Okay. Typical valve options, you'll see the live load here with the bell washers. You'll see the packing in here and the guide bearings, and we have a seal over here. So these are our typical options that we have, that most valve manufacturers as well have. Teflon, graphite, UMPI, and we do a live loaded. We make these stem extensions, and we make fugitive emissions bonnets. Now this has become a huge, in the last, say 15 years, is to have a fugitive emissions bonnet. Now ours comply and meet and exceed ISO 15848, the LDAR standard, which is the EPA's Method 21, where they use helium gas testing for leak detection. And we have passed and we are certified for ISO 15848-1. And a lot of times you'll see on ours, there is a test port here, because this sits directly on top of the original packing. And then there's a seal that's put in here, and we can check off to the side with an NPT connection for any leaks. And if we have a problem or anything emissions wise, we can check that as well. So it is really an inspection port, and it's a very, very nice feature to have. Any questions on this?
Good to go for now.
Okay, good. Here are the ball valve seats that are available. Here we have Teflon, reinforced Teflon. We have TFM 4215, which is a carbon Teflon, UMPI, PEEK, and metal seated. So these are the typical seats that you will see available. Reinforced Teflon and Teflon typically look exactly the same. One is a little harder, one smoother, so it's pretty easy to tell apart. You'll see these, note these little grooves in the seat. These are self-relieving seats. So what happens is we get pressure behind the ball, it tends to push the seat and go around the seat versus the ball staying into, or the seat staying into the valve cavity. And so these little ports, these little notches are designed and what they call self-relieving seats, to where it is going around that seat and pushing that ball still, and it keeps the seat into the valve cavity. So these are sort of a great purpose if you're not aware of that. So it's a great design. Some of the seat materials, we'll go through these. TFM 1600, which is 3M's brand name for Teflon. Teflon was actually invented by DuPont in 1938. It's been around a long, long time and has many, many purposes. The TFM 1600 from 3M is what they like to call a virgin Teflon. So everyone has their names. We just happen to use 3M for our seat materials. So the DuPont and their respective, names and trademarks, we understand, but 3M is who we particularly use. Teflon is good from -100 to 400, and we put in here for Celsius as well, because we do get a lot of international and even our friends to the north of us that use Celsius, and we are very, very familiar with all of these. Reinforced Teflon adds a little bit of glass filler to it, and it takes us to a little bit higher temperature at 500 degrees Fahrenheit. And we typically, on these applications, we will use our TFM 4215, which is at the bottom of the screen, because it has a much higher working temperature and it is a stronger material against slurries, even steam. When we say steam, we're not talking about high pressure steam here. So we're trying to utilize that TFM 4215, which has for us proven to be reliable and repeatable over and over again. It provides a great wear. Many valve manufacturers have gone to TFM 4215 or similar. You might hear the word 50/50. You might hear extreme seats. You might hear all of these words. And when it breaks down, most of them are TFM 4215. I kind of skipped over Devlon. Devlon is actually more of a nylon, and those are what we typically will use in the high pressure ball valves. They provide a great seat and great shutoff, and they do not flex or bend or twist in these higher pressure applications, but you'll note the temperature to the right that it is only good for 180 degrees Fahrenheit before it starts to change. Any questions in this area so far?
Not right now.
Okay. Peak is a nice product material that we use sometimes. What happens with peak and carbon peak and even the TFM 4215 in the previous slide is they will increase the torque. So the amount of torque that it takes to open and close that valve are higher, extremely higher when we're using peak and carbon peak. The carbon peak is not as bad as the peak, but in continuous duty, we put continuous duty on here. It actually, peak is rated to 800 degrees Fahrenheit, but for continuous duty, we like to use 600 degrees Fahrenheit and derate that just for safety and longevity. So the carbon peak, as I mentioned, it's the sister to the peak. We add the carbon filler to it, which takes us up even higher with continuous duty at 700 degrees Fahrenheit. It's been a great adder to this peak. Carbon peak has come along in the last, I believe, 10 years, and it's been a great adder to our product offering. Of these ultra high molecular polyethylene, it's a great material, and it's used primarily tobacco industry, in the nuclear industry, where they can X-ray and do all the things that they love to do, and it will not interfere. Metal seated will take us all the way up to 1,000 degrees Fahrenheit, and those are typically our metal seated valves that we offer. We rate our valves, I believe, to 850 or 900 due to the rating of graphite. So we do even, in fact, and I forgot to put that on here, is we do have a graphite seat that we offer. So that takes us up, like I said, around 850 and continuous duty. Any questions on seat materials?
Nope, nothing right now.
Okay. Last but not least, a lot of times, and we were talking about this earlier about the application and with the sticky adhesive application. One of the things that I thought about too just now might be a cavity filler, but we would have to take a look at the application. These cavity fillers, the reason we're putting these in is typically in food applications, we cannot have bacteria growing in these open cavities, and the FDA says you can't have that. So what the valve industry did is they came up with these cavity fillers to fill the voids with Teflon, and it's been the industry standard for decades now. So it's a nice valve, an option to have where we're filling in those voids in those cavities to provide a safe and reliable valve. Any questions? Okay. Here are the shut-off classifications, the TFM or Teflon as it's called. Typically all of the soft-seated valves that are available on the market today all have a class 6 or bubble tight shut-off, okay? So the classifications are based on API standards. And the metal seated, ours are rated to class 4. We can get them to class 5, but some people will say they have class 6 metal seated valve. Well, API says that you only have to do it one time. And once the test is over and the customer puts it in, the repeatability of it will no longer be a class 6. It'll end up being a class 4. And so class 4 is typically what we will rate our valves at for metal seated. Any questions?
Good to go.
Okay. For a quick comparison, okay, as we told you, the ball valve actually does float. You couldn't see it with the naked eye if you tried, but because when we sandwich the two bodies together, the ball is actually forced. You know, it kind of is a certain amount of torque that is already put together. So, but the ball actually floats into the downstream seat. They are generally the smaller sizes and typically and generally lower cost. And the seats may wear quicker depending on what seat material is selected and what valve we're using in the application. The trunnion style to the right, the ball remains stationary. So that ball is pinned at the top and pinned at the bottom. So the ball never moves. It's the actual seats that move or float. The seats move back and forth, and we'll get into that on another presentation. I think what we might do is present for you a trunnion where we can actually show you the seats moving. They're generally a larger size, generally a higher cost, lower operating torques by far, especially if you're trying to turn a 10-inch floating ball valve. And they have bidirectional sealing. So there's a quick comparison. Floating ball valves do have a lot of applications where you want cost-effective, and typically floating ball valves are readily available, and they will quickly and easily fit the bill. And with the options now for the seat, ball, body material, they have improved a lot. And the trunnion style typically are a little bit more expensive and have just about the same amount of options. So depending on your application, you know, let us know. We'll figure out if you want and we'll design a valve, if I can get my mouth to work, a valve application for you that we would best say, hey, a floating ball valve would work here, or a trunnion would work better here. So I hope I explained that correctly without too much fumbling. So it's a great thing. And then valve certifications. This is a typical valve application or certifications that we meet for all of our customers. From UL, we have UL certified valves for gas. We have NSF 61 for drinking water, FM approved assemblies for shutdowns, API, and all of the things that we're a part of. So these are some of the valve certifications that you'll see, and sometimes those valves are required to meet one or all of these specs. So anyhow,
one quick question that just came up about the certification. Do you guys also, you see FM noted, do you also carry any CSA certification?
We do. For some reason that's not on here, and I will put that on there. But yes, we do carry a CSA for limit switches, for all of our electrical. We also have CRNs that are required for our friends to the north. Yes.
Awesome.
Yeah, and each one has their own CRN for each province up there. So yes, we carry those for all of ours. Not all manufacturers do, but the bulk of them, most of them. But we do have CRNs for our Canadian friends. And that's it,
right,
guys. I just wanted to thank you for today, and thank you for letting me be here. I hope you actually learned something, and I hope I didn't fumble around too much, but I really do appreciate your guys' time and consideration today, and for thinking of us. And the guys at Peerless are are fantastic. So if you guys get a chance to work with those guys at Peerless, and every chance we get to work with them, it's always a great experience.
Thank you, Brian. We actually do have a couple of questions to cover here, and I'll just announce again to everyone, feel free to still submit questions now. We'll also leave you guys the option if you want to. You can use a function within the control panel called raise hand, and I'll get a notification that your hand is raised, and then I can actually take you off mute, and you would be able to verbally ask the question out loud, if that's something you would be interested in doing. But so feel free to do that. But for now, Brian, we do have a couple of questions here.
Okay.
So if seats wear quickly, are butterfly valves potentially a better option when talking about wear and possible leakage because of wear?
Well, typically what we look at is velocity. So velocity is the valve killer. If our velocity is exceeding a certain valve size and a feet per second, and depending on what that process is, that is typically what kills most throttling type ball valves. So considering that, we would say butterfly valves have their applications, and yes, we sell our butterfly valves all the time, but depending on what the process conditions are, we can provide and quote and engineer a seat that works for that application that we have had, experience in, and where we have tried butterfly valves or we have not. So to answer your question, it depends on velocity. There's a couple of things to look at, but the seat materials that have improved over the years, that's why we were talking about the TFM 4215, have really come a long way in the last decade or two.
Got it. We'll see if there's any follow-up. This next question might need you to reference a previous slide
Okay.
talking about multi-port valves and flow paths. Looks like we're just potentially needing some examples. Maybe you can look at a couple of the flow paths and tell us like what one, an example of an application or a reason why you would choose one of the flow paths versus another one.
Here, we're talking about this particular slide.
Yeah, so just give a quick example of one or two of them.
Well, a number of questions to ask is, if it fails, let's give an example from L3 to on the L3 up here top left. What's going to happen to the right port? Let's say we're looking at this valve in the top left at 9, 3, and 6. Okay, if the valve fails somewhere in between, someone doesn't close the valve or move the valve, what happens to the process? So there's a number of things for us to consider and ask questions that we want to make sure we don't harm upstream or downstream, and we fail in the position that is required. The number of things that we need to look at is which area do we need to protect? Are we protecting upstream, downstream? What needs to happen to this valve? Do we need it to be a fail-safe? Do we need it to have double acting and nothing happens? So there's a lot of variations and considerations to think about when we're putting a three-way valve in place. So the porting configurations, it's very important to provide, and we will tell you when we ship your valve to you, it is in the T5, and we mark inlet, we mark outlet, we mark reject, we mark them. So that way a customer, when they get that valve, they see that it is the inlet. And we've had customers even ask and request that it be stamped on the inlet flange or body to say, this is the inlet. We will not have a mistake. And this is why it's important to know ahead of time, which way are we going to protect or engineer this application.
Great, okay. Sorry, was there more?
No, I just said I hope I answered the question, because there's a lot of things to consider on a three-way valve.
Okay, yeah, we'll see if there's any follow-up. There's a couple more questions, but right now I don't think we'll need to reference the presentation anymore, so I'm going to turn it over to Kevin. But real quick, for one-way ball valves, do the valves seal in either direction?
Yes, okay, so it's a good question. If the valve is, there's a preferred flow typically for ball valves, okay? But they are bidirectional. So if you're flowing left to right and you close the valve and the pressure from the left is forcing it into the downstream seat to seal it off, and then your pressure now is going to come from right to left, so the pressure is coming on the right and we're going to push to the left. The valve is sealing bidirectional, and it works just fine. So yes, to answer your question.
Perfect. And then let's see, one last question here that may need more discussion beyond this, but maybe quickly, you mentioned them earlier, but can you maybe provide a little bit more insight into like a segmented ball valve or a V ball valve and what those are and what they do?
Sure. In our ports, let's see if we can kind of give you a better example. So instead of a round hole on floating ball valves, we can provide a V ball. So picture that circle in the middle, that's the ball, and the picture of pretty much a pie shape that we insert there. So we have 4 different degrees, and we can do a custom degree for a customer as well. But our typical are 15, 30, 60, and 90 degree V balls. And where we are controlling that flow. So we're basically making a floating ball valve into a control valve. Now, these are great applications where the pressures are low, our differential pressures are not that high. Seat material is a serious consideration when we're using V balls and throttling applications for floating ball valves. The segmented, however, you would take this ball, and it's a little bit different design. So we're taking the back half of this ball and we're actually cutting it off. So we only have a segment of a ball, and it is pinned at the bottom and it is pinned at the top. So we have this segment where we're rotating, and it is also notched. We have a 60-degree notch on ours, and it seems to be the standard for the entire valve industry for segmented valves. We also make a 90-degree segmented ball valve. But the segmented allows for higher flows, and because it's a half a ball, our control is so much easier because the torque is less, because on a segmented you have one seat to deal with, no longer having an upstream seat. So you eliminate one torque there, you have another, only this downstream sealing torque are we concerned with. Now this does nothing like, this doesn't look like a segmented valve, but to try to describe this, and like we were talking about, Dan, we may have to go with a separate conversation on this before this drags on. But
Yeah.
The point being is that segmented is half a ball, and it can provide very, very good control and pass through a lot of solids, whereas a V put into the ball may not be able to do that.
Yep. Perfect. All right, that's all the questions right now. And actually, you can see on Kevin's slide here that I just put up there, there is an image of the segmented ball that Kevin's pointing out right now. So yeah, we'll maybe have to follow up with a separate conversation on that. But for now, that's all the questions we had.
Okay, great.
Thanks, Brian. Thanks, Dan. Really appreciate your help here. Oh, sorry. Yeah, just the final screen, the shot I have here, I wanted to include a picture of the floating ball versus the trunnion. As Brian mentioned, here's the notch in the stem that would let the ball free float. And in the trunnion design, it's attached on the top and the bottom, and the seats are what move back and forth, or which would float to provide the seal. Again, I mentioned some projects we've been involved with up on that top right part of the screen. Many of you in the audience are familiar with the same projects because you worked on parts of it. We worked on parts of them with you, so thank you for that. Again, we do have valves all over the world. It's been a lot of fun to kind of track where they're at. So moving on to next week, we were ready to announce our steam traps and systems next week, but unfortunately we got notified very late that it is postponed. There's a conflict with our presenter. So in 2 weeks, we have scheduled on Wednesday, September 23rd, Filtration 101 with our partners, TM Filtration, down in Erie, Pennsylvania. They've been a part of these for quite some time. They're in a unique situation where they're both a customer and a supplier of ours. So we're looking forward to having them here on the 23rd of September. In the meantime, we do have our recordings all on our website. This one as well will be up later today. And if you have any ideas for some custom one-on-one tailored training, we also have some options there on our website. Again, if there's no further questions, Dan.
Good to go.
All right. Once again, we'll thank you for your attendance. We appreciate your support, and we will talk to you in at least in 2 weeks, unless we do have something that we can fill in for next week. So stay tuned. Thank you. Have a great day. Thanks again, Brian.
Thank you guys for having me. You guys have a great day. Thank you.
Yep. Everyone stay safe. We'll talk to you soon.